Hello, I've been working on a Philips N1702 VCR-LP format, takes these sort of tapes, video recorder from around about 1979, and I'd found that an erase head had gone open circuit. Well, much more than that. It may have been made as a cassette erase head, but actually this is being used to detect the position of a small magnet there on the bottom of the spinning video head. In the machine we're working on, the head had gone open circuit. This one, I believe, is good, so we'll just prove that and then we can install this in the machine. Without that head working, it doesn't know that the head is spinning or what speed it's spinning at, and the servos don't work and the machine shuts down. So on this one we measure around about 144 ohms, which is the sort of thing you'd expect to find on a head. So this head, I think, was manufactured as an erase head for a cheap cassette recorder, and Philips have just repurposed it. It doesn't need to have high performance, it just needs to see that magnet going past. So an erase head has got quite a large gap, it won't pick up any high frequency content. Right, so let's see if we can install that on the machine. We have a pair of screws with it, but we'll only be able to install one of the screws because the original screws on our machine had to drill one out because it got all chewed up. So here's our video recorder. This is the assembly we're going to be replacing. I'll give you a better view of that in a moment. So here is the defective head, and I'll just prove that again. So that should be reading about 140 ohms, and it's totally open circuit when it's unplugged from the board here. Now, definitely open circuit, resoldering those won't help. And we've also got some earth wiring I think we need to handle as we go along. So the wires we're going to desolder here the screened cable that goes out to this connector and these various earth terminals. We'll start with this. Okay, looking at the terminals here, somewhat confusingly, the ground terminal is red. Right, so be careful with that. Ground terminal is red and the signal is yellow. Okay, so now here's the one I'm going to be installing that came from a scrap machine, and I'd cut the wires on this, so I need to clean up these contacts on the earthing and these terminals for the pickup head, and then we can install it. Okay, so here's our salvaged one, and I will again check that we haven't open circuited anything. Good. It'll mount that way round with these earth terminals there. Right, let's do the signals first then. Good, let's just confirm now that we do see the resistance of the head up here. Good. Okay, there's not much I can do about precision setting that without some kind of jig that the manufacturers would have had, but it looks like it's in the same position as the original was. We have the complication, of course, that we can't fit that screw because we finished up with a screw broken off in there. Okay, so we can refit the head drum and the pulley and the drive belt, which, if you've been watching these you'll know is time consuming, maddening and fiddly, but you know, you get the hang of it. First thing I'll do is just drop the head on and make sure it spins without this magnet here impacting that. That seems okay. So we can fit the pulley on the back, leaving some end float. We also need to refit this connector, of course. Let's do that while we're here. Okay. Now I've got to install the pulley and the drive belt, which goes around this pulley and this bottom motor. And I've done this several times before. If you'll remember, it's extremely fiddly because this belt, the capstan belt, keeps falling off at the same time. So it's fiddly. I'll get on with that and I'll let you know when I'm done. I've been struggling with the belts as usual, and you know, I think this is the opportunity to change this capstan belt. Let's see if I've got something that fits, because that's not in good shape anyway, and part of the reason it's fighting me is because it's in poor shape and it has to be replaced. So let's slacken this off a little bit so we can get this belt off. I'll find some kind of belt for that. This machine came with some belts, and one of them might be a candidate for this, or is it too short? Let's have a look. It may be a little short, but on the other hand, this one is well stretched. So let's see if that will do the job. Okay, we have that belt installed on the capstan. I don't know, it feels a little taut, but it may be correct. Anyway, certainly in better shape than this old thing. So now I've just got to fit this awful flat belt. Okay, after a bit of struggling and swearing, belts are both installed. So that's the capstan belt, which I'm thinking is a little taut, and the drum belt. So we can try the machine again and see if we get better results. And if we do, I'll then take out this resistor, because you may remember I put that resistor in to at least slow down the auto shut off due to not seeing the head pulses, because the head block circuit was activating. At the moment we're still using the modulator output because we have not yet fitted AV outputs on this. It sounds like the drum servo is activated. Okay, I don't think the TV's tuned in properly, but it'll be good enough to start with. It didn't quite go to plan. The tape didn't run. Try that again. Tape seems to be piling up. We're having a bit of tape transport trouble. We definitely saw a hint of a picture, but this may just be a bad tape. But the tape was not being taken up by the take-up spool. Yeah, we're not getting real drive very successfully, but it could just be tape trouble. Let's rewind the tape a bit. It's sort of turning, but not reliably enough. I can rewind okay-ish, but in play, what about fast forward? Fast forward's okay, but in play it's not taking up. Here's play now, it's not taking up. That may be a bit of tape trouble, but it may also be that the surfaces that drive the take-up spool all need a good clean. So if we make it think there's a tape in there, let's switch it on. This lever down, that lever across, press the on button. And now, if somebody could please press the wind button for the play button. I haven't got enough hands. Okay, this torque here would appear to be insufficient. So it's not this one. That's fast forward. It's the reel below there. I think I need to clean the surface of that a little bit under there. Okay, that won't take long. Actually, that lower one is driven by a belt, and there's plenty of torque on that. I've proven that. I think the problem is the tape. So we'll try a different tape. Okay, that's progressing normally. Right, we'll try that with the TV. Which still needs tuning in, I think. Looks like we have something. Maybe one head is clogged. Yeah, it's kind of something, but there's a little bit of sound occasionally. Oh, that went badly. It was playing okay, and then something bad happened to the tape. I think the tape has got snarled up. That's a failing of the whole VCR format, is the tape can droop from the top to the bottom and then gets all tangled up. So I'll have to fix that before we can do any more. Okay, tape fixed. Let's rewind it a bit. And after finally defeating the TV's tuning system, I have good pictures and sound. Set the tracking up properly. There's lots of individual recordings on this tape, and they don't all seem to necessarily have the same tracking. Okay, so that's working. That's just the modulator output, and we have the vagaries of the tuning system, but it's definitely working. So next we need to fit audio video outputs to this, which I have circuit boards ready made up for. That's really looking quite good. Right, I had a number of these PCBs made up by PCBWay. They can be used in either composite video mode or S-video. I use them in composite video mode because the time-based correctors I use do such a good job. I actually find I get a better result that way, but your mileage may be different. So in S-video mode, you add the board at the top here to do the chroma, and this is then used for luma. Then if you also want composite video, you need another board to do the same thing again for the composite video. Now here's one I've made up all ready to go. I just need to add the coaxial cable and also fit the connectors. There's audio already available. There's audio that's fed to the modulator is already of the correct amplitude and impedance to feed out. It's the video signal that is not and requires this buffer circuit. Now I had a number of these made, and I've been selling them for a few quid each, just for people to, get hold of these easily. But I've been criticised. Someone's been saying, "Oh, I'm begging for money. I'm just out to make money or something." Well, I've been trying to help. So I'm in two minds whether to get any more made up now, because, is it worth all the grief? This is version 1.1. Version 1, I had those boards made in green. Version 1, the differences are fairly cosmetic. We've added an LED to tell you it's on. I've made some improvements to where the cables are mounted, and indeed where the PCB is mounted, and some corrections to the screen print. There's a version 1.2, and you can download the Gerber files. I give information on my website and on my YouTube channel on the Gerber files, so you can get these made up yourself if you want. And the version 1.2 has got some further screen print corrections. We managed to spell Steffenheimer's name wrong there, and got a voltage on the capacitor wrong there. Fairly cosmetic. These are good for N1502, N1700, N1702, and SVR 4004, which is SVC format. They all require this kind of buffer circuit. Right, so we can go ahead and install this. The way I like to do it is The audio I always put on a phono connector, and the video I always put on a BNC, but you might use phono for both. So I'll install my last populated board, and I'll think about getting some more made up. Oh, I was going to say one more thing. If you do get them made up yourself with PCBWay or similar, you'll have to ask them, if you want it, to put that scoring in so that you can snap off the chroma section if you don't want it. So you end up with, as I have, a little pile of spare chroma sections. If you want that scoring, you'll have to ask for it, and it may put the price up. It certainly put the price up for me. Okay, let's get that installed. Okay, I am armed now with my PCB, some coaxial cable, screened cable for the audio connection, phono and BNC chassis mount sockets, a new set of drill bits. But before I do any of that, I'm going to take out this resistor that I added last week, which was to slow down the auto shutdown circuit due to it detecting a head block condition. And since I've already changed the capstan belt, which was looking so terrible, I can close up the bottom of this for the time being, and all our work will be in the top. Okay, I don't think I've ever seen a wire in that position before. Service in? Oh, I don't know what that was for. But anyway, here's the modulator. This is where we pick up CVBS in and S, which is sound, and the 12 volt line, which is marked 12 volts there, and feed those through to, I'm going to drill holes in these blanks at the back for the audio and video connectors, and then pop the circuit board in the bottom. You could come up with some nice way of mounting it in there, but I'm afraid I don't. I just drop it in with a bit of hot melt glue, leaving this preset control available for adjustment of the gain. The bit that seems to slow me down most is stripping and soldering this very thin 75 ohm coaxial cable. The center conductor is really small and it's quite fiddly, so it's a bit boring. I won't film it. I'll just let you know when it's done. Okay, that's installed. Let me show you what I've done. So the video input signal is connected here to CVBS in. That's composite video blanking and sync, but that's what needs to go to the buffer circuit. Then it's 12 volts is picked up from here. That point there is 12 volts. And the audio is picked up from, well, you can't quite see it, but it's this track here that goes to S for sound. And then we go down to the board at the bottom, which I've not quite secured yet, because I want to test it and set up the gain level here. And then the audio goes straight out to a phono socket, and the video out from the buffer goes to a BNC socket. And I've applied some hot melt glue, especially for the BNC one, because otherwise there's a tendency for it to spin when you fit the connector. So I'll connect that up to the monitor now, and then we can see, we'll set the gain level at least roughly right. This light should come on to indicate the 12 volts. Then that should be the machine going. Actually, I'll switch on the 12 volts now, and we'll just confirm that light. So switch machine on. Right, so we have 12 volts. It takes a while to switch off, not just because of capacitors, but it actually holds that 12 volts on there for a while. Right, let's hook up the monitor and test it. And it looks like we've got the luma level roughly right already. See, there's the gain setting. That looks pretty good already, just in the middle setting there. Right, I'll apply a dot of glue at the bottom of this board to hold it in place. You could come up with better mounting solutions, I'm sure, and we can put the machine together. Well, that's come out really well in the end. I'm delighted with how well this machine performs. Except, of course, I haven't managed to bring one more VCR-LP format machine into the world because I had to borrow the heads out of a good working machine. So I'm still desperate for some more N1700 heads. If you should have some, whether you think they work or not, do let me know and I'd love to test them. The other little detail was this. I never did work out where the spring came from that fell out the bottom of the machine. There's a possibility it's nothing to do with this video recorder, but I suspect it probably is. So if you've got any idea what that spring was for, do let me know. Right, I hope you've enjoyed what we've done here. I'll do plenty more content on audio and video technology in the near future. Bye for now. Okay, drive belts. This awkward one that upsets me so much, the head drum flat belt. I found a really good eBay supplier for these. They're very sensibly priced and really quick turnaround as well. They seem to know what they're talking about, so I'd highly recommend that supplier. Information on screen. 76mm by 5mm flat belts. For the capstan belt, this one's a little bit tricky. It's a 2mm cross-section area. I reckon about 114mm diameter, give or take, would be correct for one that's not stretched. I've ordered a range of them from an eBay supplier that do, apparently, 2mm cross-section area belts. We'll have to see when they arrive if they're satisfactory. The other belts here, they're more like normal cassette belts, 1.2mm or something like that. So they'll be easy to source just based on their dimensions.